So we've got a word problem here, and what we're saying is that a medical study has shown that the first 20 days of radiation therapy, a particular type of malignant tumor decreases at a rate according to this function right here. Now look, here's what it says. It decreases at a rate. Now, decreases at a rate, that's a derivative, right? When you see decreasing, you're thinking derivative. Rate, you're thinking derivative. So here's what we're given. We're given that m prime of t is equal to negative 0.018 t squared plus 0.02 t. So in this problem, m, right here, represents the mass in gram of the tumor, and t is the number of days since the beginning of radiation. So you can see here, the change in the mass depends on the number of days that have gone by, according to this function right here. So let's keep going. What does it say? Now, if a tumor of this particular type has a mass of 150 grams just prior to the start of radiation, then we have some questions. All right, so here's what we know. Just prior to the start of radiation, so no time has gone by. So what we know here is this. We know that when t equals 0, right? T is the number of days since radiation started, but we're before radiation, so t is 0. We know that m is equal to 150. So there's an initial condition. So the first question here is this. Rounded to the nearest tenth, at what rate, so I'm thinking derivative, at what rate will the tumor be changing in 15 days? Well, this gives the change as days go by. So in part A, what we're going to look for here is, right, let me see if I can get it to right. In part A, we want to compute m prime of 15. So we're going to get negative 0.018 times 15 squared plus 0.02 times 15. Now when I did this on my calculator, I got negative 3.75. So what that means, of course, if we write it as a fraction, right, it's negative 3.75 over 1. So at day number 15, if we increase, right, we're out at day 15, if we increase it by 1 to 16, the mass will go down, right, decrease by about 3.75 grams. Now, this is almost the same problem, except I want m prime of 20. So what happens after 20 days? So I'm just going to put the 20 right back in here, right, put the 20 here and here. I'm just going to do it. On my calculator, when I did this, I got negative 6.8, or if you like, how about negative 6.8 over 1. So 15 days out, if we went from 15 days to that 16th day, we would have lost 3.75 grams of that tumor. But if we're out to day 20, right, 20 days after radiation starts, if we go one more, from 20 to 21, we're losing 6.8. So this thing is shrinking pretty quickly now. And in part C, what we really want here is, let's read it carefully, rounded to the nearest tenth. Well, I guess I didn't round that to the tenth, so I'm thinking 3.8 here. If I pay attention to the instructions, 3.8. Okay, so anyway, let's get back to this problem. Rounded to the nearest tenth, what will be the mass of the tumor in 15 days? Now, not how it's changing, just what is the mass? So we're given the derivative. That's how the mass changes. What we want is the mass itself. So we need to anti-differentiate this function to get back to the mass. So what we're looking here is this. We want the antiderivative of m to the t dt. So we're going to have, in this case, m prime is negative 0.018 t squared plus 0.02 t with respect to time. Let's anti-differentiate. We'll get negative 0.018 and then t cubed over 3. Believe it? Increase the exponent by 1, divide by that new number, and then plus 0.02 t squared over 2 plus c. Let's simplify a little bit. 3 will go into 18 6 times. We're going to get negative 0.006 t cubed plus, that 2 will cancel with that one, leaving us 0.01 t squared plus c. And now we know that when t is equal to 0, m is 150. So I'm going to put that 0 here and here. And this one's nice, it just pops right out, right? Because if you put in 0 here, anything times 0 is 0. This whole thing goes to 0, this whole term goes to 0. And we're looking at now, we are looking at, I'll do it right up here, this is c equals, okay, 150, right? That whole thing was 150, so c is 150. So what we have now is, boy, you know what? I'm going to do this way up here at the top. I'm going to go way up here. So hold on. So here's our antiderivative, negative 0.006 t cubed plus 0.01 t squared plus 150. Right? This is the mass. So just reading this now, it says that t equals 0, the mass was 150 grams. So when you start out at day 0, you're at 150 grams. Now we want to know is, what's it going to be in 15 days? We already know how it changes in 15 days, so let's just put 15 in here. So let's do that. So I'm going to get, oh, you know, I'm running out of space here. So it's going to be, I'm going to jam it in here. Okay. So let me jam it in here. This is going to be negative 0.006 times 15 cubed plus 0.01 times 15 squared. So I'm getting 132. All right, so now I'm just going to come down here where I got a little bit more room, and I'm going to say this. The mass of that tumor after 15 days of radiation is 132 grams.